Hi everyone, and let's take a look at this basic C file right here. We are going to stream it using the cat command. Let me hit enter, and we have our routine header for standard in and out for this C file. We then go to our main method right here, similar to Java. This is where all the action occurs, and it's returning an int or integer. The parameter is essentially nothing. It's a void. We then present our first variable. It's going to return, or it's of type int or integer. And you notice all we are doing is initializing it. We are not declaring a value to it. We could, but we're choosing not to. The way C works is before we mention the variable, it is kind of like other languages, other heavily typed languages. We actually have to add the variable type so the compiler knows what type of memory to reserve, and not what type, but how much. In many languages, an int or integer is around 4 bytes. So as you're creating larger and larger applications, it is best practice to be able to predict about how much space your memory is going to need for these various individual variables. So, anyways, um, and then we have to end it, any statement, like many other languages, we have to end it in a semicolon. Now it's doing a format print, and it's printing. Please enter a passcode with a colon and a space. Now notice there really is nothing special about this string literal. That's what you call anything between quotes, a string literal. And so they call it the string literal because they're trying to differentiate this string literal from those return type characters. That being said, we do have access to those with the print format. But anyways, this is where it asks the user to please enter a passcode. The next command, scanf, actually scans what the user has put in. Now this ampersand, I believe, although I am not an expert at the C language, I believe this ampersand stands for the memory place in memory that contains the user's input. So it is taking the user input using the print formatting print line. The user sees this, and whatever the user puts in, it scans it in and presents it to be equivalent to the passcode variable. Now it's saying if what the here is if the what the user has put in is compared to this 1 2 3 4 5, and if, for example, the passcode does equal 1 2 3 4 5, if true, and in double equals, the return type is a boolean. So it's saying if true, that's what this phrase means, then it'll say success. And if it isn't success, it literally, if the passcode variable, if whatever the user puts in is anything other than 1 2 3 4 5, it will print failure. And here it's simply returning 0. Now let's see this in action. Let's run it. So this is fake pass 3, and let me try a password 45 failure. Let me try it again. Let's DEF. That's a failure. Now let me do 1 2 3 4 5, and it is a success. Now we have seen the fact that this actually works. So how does this look when it's disassembled? So we're going to go into our IDA right here. We're going to double click on it and we're waiting for it to start. We're going to hit OK. We're going to go to new and let's just click on fake pass 3. That is, of course, the execution file. And just so everyone knows, I am on an iMac, okay, but this is an Intel based iMac, so it's a kind of a little bit of an older machine in terms of architecture because the latest machines are the M1 through honestly the M5 series, and you know the M6s are coming out soon. And to me, there's not. I do have an M1 and an M3, and to me, there's not that much difference between the M3 and M1. The M3 is a little bit more snappy. The image, the screen is a little bit better, but really, all you need is the M1 to survive in this world. So, anyways, this is where the fun begins right here. This is where the most, I guess you could say, where the most familiar assembly calls are. And thankfully, we've been working with assembly, so some of these should look familiar. For example, it is moving the RSPs, probably a pointer on the stack, and that register stack pointer, it's moving that into RBP, and that would be another pointer. And it is moving values around, and you can see here where it says please enter a passcode. Okay, so it's entering A, please enter PA, please enter APA. That is going into RDI. Okay, but here is the thing. We see the difference between the paths, if you will, of success and failure. And what it's saying is that well, you might be asking where exactly is it comparing, and that would be here, CMP. This is where it is comparing what the user wrote and what the password actually is. And we're going to presume that we're saying if it doesn't match, it's going to say jump NZ. So jump NZ stands for jump when it's not 0. So anytime when you have the comparison here, it's going to be 0. But if it's not 0, it's going to go here, which matches up the failure, which is 10000 and here is location 10000 Now, if you're wondering, okay, they name this location failure. So what is this? So if you look at this and then you look at rename, you can see that the address is the same, except instead of ending in B8, it ends in A8. So we have our two paths right here. I am not going to show you how, for example, we can take this location and just change the B to an A. The effect of changing the letter B to an A is that it's saying that no matter what the user puts in, even if it doesn't match, it's going to it would jump to this success. So what we're like, you could easily see, how we could influence the executable logic, okay, by changing the location of where the program inevitably will jump to. And if we change it to jump to A8, which is this, instead of B8, which is this, then we will have successfully hacked this program into bypassing the password. So imagine how wonderful that would be if this was as simple as this. But this course is just an introductory. The idea here is once you understand how to read this on a very basic level, which is what we're doing, you can on your own after the course is over try to try to jump over password requests for other, more marketable games and things like that, like Red Dead 2 or something. Anyways, the other thing I wanted to show you was you can go to view and then open subviews, and then you can see these strings right here, and you can see that this has to do with entering a passcode and going and looking at success, and you can see that it says 1 point in memory it says success, and another point in memory it says failure.